Hello everyone, this is Akash. Welcomes you all into the first episode of my LinkedIn initiative series, that is VLSIpedia. In this series, I'm gonna make your basic VLSI concepts crystal clear, covering both front end and back end in simpler way. Now, let's start today's video. The topic for today's video, it is the logical switching of the CMOS inverter. So we everyone have performed these experiments of the logic gate table verification. It may be the TTL or the CMOS ICs of various kinds of the logic gates like NAND, NOR, AND, OR, XOR, NOT, etc. But if we go through these datasheets of these ICs, you will find something interesting. So in our lab, we generally for the experimentation, for the logic 1 input, we connect the probe to the plus 5 volt supply, and for logic 0 input, we connect the probe to the ground. Going into the little day, if we refer this datasheet like I am showing here, the datasheet of IC4069 CMOS hex inverter, that is that of the NOT gate. According to datasheets, talking about the input for VDD is equals to 5 volts. It is a power supply of this 5 volts. Maximum value of this input for the logic 0 voltage is 1 volt, and minimum value for the input of logic 1, it is a 4 volt. Or if we refer this output data for this VDD, again power supply 5 volt, max value for this logic 0 output voltage is 0.05 volt, and minimum value for this logic 1 output is 4.95 volt. So collectively we can infer that for any input voltage between 0 volt to 1 volt, it will produce this output voltage as 4.95 volt to the 5 volt, and any input voltage range between 4 volt to 5 volt will produce this output of 0 volt to 0.5 volt. So as due to this inverting nature of this NOT gate. But these values are a prototype into the nature and changes with respect to the IC manufacturing logics and various kinds of the companies. But ever you thought, what if we apply the input say 1.5 volt, 2.5 volt or 3 volt to this inverter? Now one can say input between the 1 volt to 4 volt is invalid in this IC fabrication. Yeah, that's true fact. We have all learned this into the digital logic family with the various kinds of this logic like TTL, RTL, CMOS, etc. But why? Why this is invalid? Like what happens at that particular nanometer fabrication that this voltage range is totally gets denied from the semiconductor companies? So for this answer, I can give this answer in the next 2 to 3 minutes. So I'm gonna explain all the things into simpler way with this help of this CMOS inverter. As you know, this is a particular CMOS inverter consisting of the one PMOS and one NMOS into the cascade manner, as well as we all are aware about this transfer characteristics. It is a typical, you can see here, it's a typical CMOS inverter characteristics of this output voltage is at the y-axis and the input voltage at the x-axis. So at the first sight, this transfer characteristic look too complex, but don't worry, I'll make this thing simpler. So this second transfer characteristics, looking at that particular this characteristics, we can infer that the output voltage is almost constant and is of this 5 volt for the input range of 0 to 1 volt, and also again the output voltage is almost constant, that is 0 volt for this input range of this 4 volt to 5 volt. So as we can see here, and this is our typical voltage range that required into this data sheets. But you can see here there is a sharp curve, that is the voltage is dropping very sharply at this particular voltage 2.5 volt. So basically this particular voltage is called as a switching threshold voltage or logical threshold voltage, and it is generally at the VDD by 2. There is a half of the VDD voltage in every CMOS transistor. As we have 5 volt supply, it's a 2.5 volt, and no doubt this particular voltage, the 2.5, this particular voltage can be manipulated by various kinds of this transferring IC parameters like channel length, channel width, mobility, oxide capacitance, etc. So collectively, this is called as the switching of this CMOS transistor. Like output is switching into very drastically from this very high voltage to the low voltage. But why? Why this is a sudden curve and the sudden voltage change into the output? So as we can see here into this CMOS gate, the drain of this PMOS and NMOS are sorted together. There is a drain current flowing from this PMOS and NMOS must be equal. And from these characteristics we can see that at this particular stage, at this particular sharp curve, both NMOS and PMOS transistor are into the saturation region. As we know, the MOS transistor can be either into triode region, saturation region, or this cutoff region. So at this particular stage, the both transistors are into the saturation region. So as due to these conditions, the saturation current flowing from this PMOS and NMOS must be equal. That is to satisfy this basic circuital laws of the KCL and KVL. So these are some calculations. As I told, the drain saturation current flowing from this NMOS and PMOS must be same. I have written these equations for this PMOS drain saturation current and NMOS saturation current. We have to satisfy this condition, and by doing some calculations we get the final equation. The final condition is that the aspect ratio, so the width, the ratio of the width to the length of this transistor, it's called transistor channel, is called as the aspect ratio. So aspect ratio of this PMOS transistor must be 2.5 times greater than that of this aspect ratio of the NMOS, so that this particular condition will get satisfied and the current flowing from this transistor will remain same. But what happens at this fab, like at this nanometer level, where the thousands of inverters circuits are fabricated within a single wafer, manufacturing this particular condition becomes too crucial, and hence the current flowing from this PMOS and NMOS gets fluctuate. And as we know, these are the transistors. It may be PMOS or NMOS. These are the transistors. Hence, it will have some output resistance, and this fluctuation current can cause this voltage drop across this PMOS and NMOS, and due to this fluctuation current, output also fluctuates. So that's the reason that the voltage is fluctuate into this manner, because the width and this length of this channel and the oxide capacitance, all these things are plays very crucial role at that particular fabrication level, and minor changes into these things can create the huge difference at this hour stage. So this particular reason is that this NMOS and PMOS are both in the saturation, and this we can see this sharp curve here. And that's the main reason that from this input voltage 1 volt to 4 volt, we consider it as invalid, as the output is not constant, it is varying drastically in this particular voltage, and hence input voltage from this 1 volt to 4 volt is denied. So similar concept applies into other logic gates, as ultimately it's a game of the CMOS logic. So that's it. So from now, if someone asks you why this input voltage, input from 1 volt to 4 volt is invalid, then you can surely answer them into the very detailed manner. So that's it for today. If you like the video, don't forget to hit the like button. If you have any queries or the doubts, let me know into the comment section. Thank you for the listening, and I'll see you into the next Sunday.